7th term was the first term that was lower than this. Then you need to add up the first 6 terms. You got it. You got it. And what I'm going to do, everyone, I'm going to delete these out and see what the sum would be. Now we'll just see. What would happen if I went in here? Let's see. I'll go down here. We only have to add which terms? The first 6 terms, right? All right, delete. Delete. Over here. Delete. Delete. And I'm just going to hit quit. I'm going to hit second stat. I'm going to arrow over to math and get this sum button. And which list should I sum, Dave? L2. I'm going to sum L2. So I'm going to hit second 2. And when this, right here, this sum, 1.017, I'll hit the light so we can see that.
Wait, I think that's wrong because you left the 6th term in there.
Oh, is the 6 terms in there? You're the best, because we only got to add the first what?
5.
The first 5 terms. So I'll take that out. This would keep it more accurate, the more terms we add, but we only have to add the first 5 terms. The first 5 terms. And Isaac, thank you. I'm going to make sure it's only these terms that we need to add to get this desired accuracy. So I'll go back in here and knock those out. We don't need that. Hey, if I kept it in there, it just gives it more accuracy. Does everyone understand that? The more terms you add, the more accurate it will get. But we're saying we only need to add these first 5 terms here. I'll hit the light. Just so everyone can see. We only have to sum those first 5 terms to obtain an accuracy to be as close to the actual sum to be within there. And I'll do it again. I just want to see what that sum is. It's going to be very close to what we had before. Hey, what is the sum of L2 now? Close braces. And 1.01730.4. And that'll give that accuracy. This is accurate. Having an error less than this. Cool. Now, did I put the negatives in there? Did I put the negatives on those?
No.
So I have to, that's the one thing I gotta be careful of, everyone. Would this be mathematically correct? Because I didn't have the what?
Negatives.
Were the negatives in there? Connor?
No.
So I gotta make sure I'm adding the what? The negative and the plus, and the negative and the plus. We gotta add those in there, true? So just make sure that I'm adding those into this. I can just go into that list and put those negatives on there. Which ones would those be? Second left. Was the second term negative?
Yeah.
Yep. So I'm just going to insert. Just a little negative symbol right there. No problem. What I'll do is I'll enter this again. That edit. I'll go up here and I'll just hit clear and hit enter. And I'll now just enter the actual formula. What was it? I'll type parentheses -1.
You're in the wrong spot.
Oh, let me get up to that next one. Thanks. -1. Caret. This is raised to the
plus 1.
And I gotta do L1 plus 1, correct? L1. Plus 1. Now I'll write R down. What's this multiplied to?
It's divided by L1 to the 6th.
L1 to the 6th. Raised to the 6th. Now, in that you're impatient, I do have to keep that in when I'm going to think about what's the actual sum, because this was negative and this was negative. This one was positive, this was positive. This one right here, first one, keeps alternating between the positive stuff. Positive, negative, positive, negative, positive. This was negative, but did we need this? No. All right. And now second quick. And I'll just say clear screen so we can focus on this. We are now going to sum number 5. Sum L2. And we now have the desired action. 0.98556. And that's how accurate we are. Cool. Hey, so try another one of these. And super job with this, everyone. I'll make sure to keep those negatives in there so we know that we're actually adding up the right terms. This one, how about -1 to the n? So we're in factorial. I'm going to change the direction slightly. So this is what I have for this one. How many terms of the series do we need to add to be accurate to 4 decimal places? How many terms of the series we need to add to be accurate to 4 decimal places? And secondly, approximate the sum to 4 decimal places. All right. -1 to the n, all over and back. Well, we'll make a little chart here. And an eighth of n, right? 1, 2, 3, 4, 5, 6. I don't know how far we're going to have to go, so I'm just going all the way out here. 7, 8. If we need more, I'll make another table. Hey, just plug it into 1, what do you get? Is it positive or negative? What's 1 factorial? -1. Plug in a 2. 1 over 2. Plug in a 3. What's 3 factorial?
6.
So this is 0.5. What is -1/6 in the decimal point? What do you get from -1/6?
0.1667.
0.0667.
No, 0.1. 0.1667.
0.1667. Okay. And we'll just continue this, but I'm going to look for the what? 4 decimal places. What do we mean by that? And let's just think, when we see 4 decimal places, let's look to when we have a decimal point, and we have a 0, and a 0, and a 0, and a 0 at least. That sound good? That's what we're going to look for. So this could have like a, this could have a 9 here. This is what we're looking for. Look for this when we get this to come up. So we have 4 decimal places. I'm not there yet, am I? Well, I'll use that screen. And I'll hit the lights. clear. Clear screen. Let's do it again. It should be hard. I'm going to go to Stat Edit. Stat. Actually, I just did Enter, so Stat Enter. Up arrow, I'm going to hit Clear. Enter. Up arrow, hit Clear. Enter. 1, 2, 3, 4, 5, 6, 7, 8. That's far enough. Arrow right. So what do I type in here? Don't use X, use L1, right? I'm going to do parentheses. Yes.
You gotta jump up to the L2.
Oh, thank you so much. Wait, I gotta get that first one. Up arrow, and I'm in L2 right here, and I will do parentheses, -1, close the parentheses, raise to the L1, and now I have to divide what?
L1 factorial.
Where's the factorial? I'm going to hit L1 factorial. Where is it? So I hit, there's L1, everyone. I'm going to go to Math, and then arrow over to Probability, and it's the fourth one down. And I'll hit it. And I'm like, oh, cool. This way I can see a list and just concentrate. Now, keep in mind, if you don't like using this list, it's no problem just doing these on a blank screen, finding these numbers. Which number gives me a 0, 0, 0, 0? The 8th term. Aha, so in the 8th term. Gives me 2.5 e to the -5. 2.5 e to the -5. What's that in decimal form there, Andrew? What would that be? 2.5 e to the -5.
0.000024.
And when this was the first number where we had these 4 zeros in a row, isn't it? So which term do I have to add up? This was the first number where we got that accuracy. So, we're going to add these numbers right here. Now make sure, negative, this is positive. Negative, this is positive. This will be negative, this will be positive, and this will be a what? Negative. So, I'm going to answer letter A right now. How many terms of the series do we need to add to be accurate to 4 decimal places? Is this correct? That's what I worry about on the test. Is that a correct answer? No. How many terms? The first 7 terms. So I'm going to make it 7. The 8th term was the first term that gave me that desired accuracy, so I need to add the first what? 7 terms. I'll even put the word term with it, so you know. Does that make sense? Okay, good. And they want us to approximate the sum, so I'll go back to this. I'll make sure I got my negatives and positives this time, and I only have to add up the first 7, right? Hey, what if I accidentally leave that 8th term in there? Will I still be correct? I want to know that. Will it still be accurate? Yeah, the more terms you add, the more accurate it gets, right? We're just saying you only have to add this.
So on a test, it's fine if you just don't.
Of course. Like, what if you accidentally, like, maybe someone missed this problem, but on this one, think about it here. What if they added the first 12 terms? They're going to be correct. Because it's going to be accurate to how many decimal places?
Okay, that's fine.
It'll even be more accurate, but it'll be accurate to 4 decimal places. Does that make sense, everyone? The more terms you add, this is for who? The computer programmers. This is for the programmers who say, hey, you save time, and when you get the, just adding these terms, you get the desired accuracy. That's what we're talking about. All right, so I'll hit the light. I will knock out that 7th term, or excuse me, that 8th term. You know I didn't have it. To do this sum. I'll go in here, let's see. I'm going to delete that. I'm going to go over here and delete this. And when I have my negatives and my positive numbers in there, just to double check, negative, positive, it's alternating. I just want to make sure we didn't forget that. Good. I'll hit second quit or second mode. And I'll go to list. Whoops, second. Yeah, there we go. I'm going to go over to math, use that summation button, and I'm going to sum which list? L2. And I only have to go to 4 decimal places, right? Negative 0.6321. That's my answer. Negative 0.6321. I do want to point out, what's the number after the 1? What if the number after the 1 was a 7? What should I do here in my final answer? Round up. 7 got that? You got it? Any questions on that? This theorem's awesome.
So in the case of like if we're doing this on the test, just like we put in like up to 10 terms and the list and we sum it.
It's going to be more accurate. Like I didn't have to delete that one, right? Exactly. The more terms you add, the more accurate this will get, but it'll contain that accuracy that you want. The toughest thing I think is answering that question. That's the one we got to be careful on, right? Juliet, that was the one we had to find. What was the actual place that we had to get that desired accuracy for the first time? How about that for the first time? But the more and more terms you add, it just gets more accurate. But we want to save time when it comes to programming. We want to save time, or you don't add up to 100 every time. You only had to add 7 terms. Hey, cool. Hey, great job, Hal. Turn this off. Hey, the last thing we do is the ratio test. Oh, you'll like this. The ratio test. Good job, everyone. Hey, if that list stuff bugs you, I get a lot of students over the years, they go, I don't like playing around with that. They just get them on the front screen, write them down until they get the number. And you'll notice, even with that, me working that thing off that computer, I'm used to working it off of what? This thing. It's so much easier to use like Microsoft Excel. You know, I used to be practicing this stuff at home. I know it's easy to use something like Microsoft Excel to look at this stuff. Okay. So now, the ratio test. This test is outstanding. We're going to look at the limit as n approaches infinity of a ratio of a sub n plus 1 over a sub n in terms of some series. And we'll see if that limit exists. If the limit's less than 1, then the series is absolutely convergent. If the limit's greater than 1, the series is going to be divergent. If the ratio we get turns into a perfect 1, we can't use this test. We'll have to use another test. Okay? So if you fall in love with this test, just be careful. When you get a limit equal to 1, you can't use it. You're going to have to use one of the other tests. I had the word absolutely convergent here. And that always gets students going. They're like, why did you write that? So I'm going to talk about what absolutely convergent is. It's just a stronger phrase. It's a stronger phrase that can be used in terms of convergence. So I want to give an example of a series that isn't absolutely convergent. This one. And when that series right there is not absolutely convergent. But this series is convergent, isn't it? This series right here, is this convergent? It is. By what test? This converges by the alternating series test. Will you check it? It's alternating. The terms of these are what? Decreasing, right? And what's the limit? Let me hide that. What's the limit as n approaches infinity of v sub n? 0. So this is converging by the alternating series test. But I want you to tell me something. What if I do absolute value bars on this? If I do absolute value bars on this, what would you get? You get the summation of this. And what do you know about that series? This diverges because it's a what? It's our harmonic series. So what I'm saying is, series right here, we can call, it's convergent, everyone. It is a convergent series, bialternating series test. I just can't call it I can't state that it's absolutely convergent. All right? So to be absolutely convergent, we're saying you got a series that's already convergent, you can put absolute value bars on this portion, and that series is convergent. Cool? So that's what that absolutely means. All right, so let's look at a problem. Where can this be helpful? And this is an 11.6. This is number 3. From 11.6. 1 to infinity. We got an n over 5 to the n. And what I'd like us to do right now is think about all the other tests we've used so far, and then we'll apply this ratio test. Geometric series test, can I use it? I want to see whether or not this converges or diverges. Is that geometric? Be careful, it's not because of the what? The n. Does that make sense? It has to be all exponential. I can't use that. How about test for divergence? Well, what's the limit of that sequence? Going to 0, I can't use that. How about the integral test? Maybe I use the integral. Does anybody know how to integrate that? Right? I know we're sitting there going, oh, we don't integrate stuff like that. So this is where the ratio test can be really handy. I got a mixture of a polynomial or a monomial with an exponential. And none of these other ones are working for me. Integral test, test for divergence, GST. Ratio test can be very handy when you have some type of monomial mixed with an exponential. Or maybe a factorial with a monomial with an exponential. So what we do is, we start by taking a limit as n approaches infinity, put some absolute value bars, and you have to find a sub n plus 1. Do you know what I mean by a sub n plus 1? I need you to substitute. The word is substitute for n plus 1. So if you substitute n plus 1 there, what do you get? N plus 1 over 5 to the n plus 1. And I'll put a long fraction bar. So there's a sub n plus 1. Does everyone see what I did? I just substituted what? N plus 1 for every n. Now, underneath it, you just put the original a sub n sequence, which is n over 5 to the n. We're going to find this limit. And if this limit is less than 1, this series is convergent. If it's greater than 1, it's what? Divergent. So it's a cool test. How do you divide fractions?
What do you apply?
So when I'm going to do that, I'm going to just take this n plus 1, 5 to the n plus 1, put a dot, flip that over, right? Hey, can I take off the bars now? Is this always going to be positive? Yeah, so I'm gonna, if you want, you can keep the bars there, but does anyone notice this would always be positive terms? Nice. Now, we need to, so how do you rewrite 5 to the n plus 1? Way to go, Adam. Does everyone hear this? I'm going to write 5 to the n plus 1. This is important. As 5 to the n times a 5. I'll use millitron. This is extremely important when doing the ratio test. Adam is doing that so he knows what cancels. So I rewrote 5 to the n plus 1 as what? 5 to the n times a 5. Like, how could you rewrite 7 to the n plus 1? How could you rewrite that? That's 7 to the n times a 7. I think you got it. Let me try one more. How would you write 11 to the n plus 2? I'm trying to get you. What would that be? 11 to the n times 11 squared. And if you're rusty on your old algebra, you know, just put that in your notes. I know. Hey, does anything cancel? So let's rewrite that, because it looks all sloppy. What do we have there? What's the limit of this? The worst thing is when a student does this math and he cancels things out correctly and then they tell me the wrong limit because their eyes missed something. It's all sloppy. Let's rewrite this. I've got an n plus 1 over an n. And what's that fraction right there? 1 what? Isn't that 1/5? Anybody know what this limit is? You can do L'Hopital's rule, bless you, or you can think of a rash, poor ass. Powers are the same, what's the whereas?
1/5.
1/5. Does everyone recognize this is the limit of this sequence right here?
Where did the 1/5 come
I just took that 5 and put 1/5 in front.
from? Oh, okay.
You could write it like this, but sometimes, Connor, that can bug you. You can sit there and go, but you may prefer that. You could have written it like this too. So if you, Connor, anybody in here prefers to write this like this, that's totally fine. I'm gonna write it both ways. I'm gonna let you all choose which way you would prefer to look at this when you're finding the limit. Because the key is you just want to find that limit. Can I do Lec Pt.2 rule? Sure, what's the derivative of n plus 1? 1, what's the derivative of 5n? 1/5. Or you might think, oh, there's a horizontal asymptote. That rational progression. Is this greater than 1 or less than 1? Final answer? This series converges by which test?
RT.
By RT. What a cool test. What an awesome test. We'll do a couple more of these. And when the thing about the ratio test, when is it useful? This test, I mean, there are multiple problems we've done previously where you can use this. It's not so great when you get what limit. You do all this math and you go, I get a 1. You're going to have to go to another test. That's what I mean, if you really, really dig this test. It is exceptionally well, though. I want to tell you where. When you got a mixture of exponentials and polynomials or monomials, because integral test, geometric series, no way. Test for divergence, well, the limit was already 0. We can't do that. The limit of the sequence. Do you follow me? Whereas the limit comparison test, maybe, but this is just such a cool test. All right, let's try another one. Does it converge? It doesn't diverge. This is 11.6. Okay. This is number 8. I know the even answers are in the back of the book. And in fact, turbo 100 to the end. Now, some of you might already know the answer, but I'm going to pretend like we didn't know it. You might already know this answer by another test, but I'm just going to go through the ratio test because I like the ratio test. Here I go. The limit, as n approaches infinity, of, what do I substitute for n? N plus 1. What do I substitute for n? N plus 1. And what do I divide? That's a sub n plus 1, right? And what goes in the denominator? The original. So it looks all scary right now, but we're going to clean this up. Hey, I got bars here, but do you recognize everything's already positive? So if you want, you can remove those bars right now. You can remove the bars right now because everything's already positive. Everything's positive. Let's do the flip. Flip it. Right? N plus 1 factorial. 100 to the n plus 1. Put a dot. Flip that over. 100 to the n over. N factorial. And I was going to wait till everyone gets this written down. You're going to help me rewrite all this. Like, how do I want to write 100 to the n plus 1? Jessica, you were awesome. She goes 100 to the n times 100. I'll do it. Very good. Anybody know how to simplify this right here? We need to be able to do that. How do you simplify that? How do you simplify n plus 1 factorial over n factorial? So let's think about it.
N plus 1.
Way to go, Dave. It's just n plus 1, isn't it? Remember, this is n plus 1. What's 1 lower than n plus 1? And what's lower than n? 1 lower than n. N minus 1, what's this? N minus 1. Keep going. What's this equal to? N times n minus 1. What's going to cancel? Isn't this just n plus 1? By the way, some of you write this as n plus 1 times n factorial and let the n factorials cancel, right? But you see what we're saying? This is just n plus 1, that portion right there. If you got factorial over a factorial, you can always simplify. So let me rewrite all this. What do I now have? Keep it nice and neat. I now have the limit as n approaches infinity of n plus 1 all over 100 because this cancels. Does anybody know that limit? What's the limit as n approaches infinity? N plus 1 over 100. It's heading towards infinity, right? So what's my answer? By the ratio test. This is way better than that alternating series test. We had to go to another test. It has a test for divergence. What happened is your limit is greater than 1 or not, or infinity. In this case, it's infinity. What can I say? This series diverges by the ratio test. The ratio test. Pick the other way and I'll light your copy. I'll pick another one. I want to match some of the problems that with your practice. I wish we were like 7 or 13. What do y'all think of this test? Isn't it cool? Awesome test. It's weird because we waited to the end. It's kind of like the cleanup. Like the cleanup hitter, it's the cleanup test. Hey, none of my other tests work. Geometric series test, integral test. We'll try the ratio test, right? Hey, I'm curious, did anybody have another test you could have used? It probably would have been less writing. Test for divergence. You are awesome. She said test for divergence. She recognized at the beginning factorial over an exponential, right? She knew this limit right here. She knew that limit does not exist. The limit of that sequence is going towards positive infinity, does not exist. She could have just TFD. One sentence. She would have been done. But, you know what's great? Maybe a lot of you like the ratio test and you want to use that to do the problem. There's nothing wrong with that, true? So some of these tests have multiple answers. Others might just be like only one test. Hey, great. Hey, sometimes the ones that look so simple can be the ones that can be confusing. Did you notice I have a fraction over a fraction? And when this is one like number 7, where it's so small in terms of the writing, there's not much. You might think, did I do it right? Oh, they use K. Every once in a while they use a K. I'll use K too. They use the fraction 2/3. I think I'll use 3/4. All right. There you go. This is my point. There's not much there. There's not much there. K times 3/4 to the K. Is this a geometric series? Be careful. Geometric series would have been just that. Right? Here's a geometric series. Maybe something like this.